Welcome back to the Earth Science Classroom. So today we're going for a little tour of our solar system, and this diagram basically looks at all of the original 9 planets, including Pluto, in terms of the Sun being in the center and the most mass of our solar system at 99%. You've got the terrestrial planets, the gas giants and ice gas giants, and you have this clear pattern organization of our solar system due to both Kepler's laws and Newton's laws. So the first 4 planets are called terrestrial planets. These 4 are the closest to the Sun. They include Mercury, Venus, Earth, and Mars. Now these are composed mostly of heavier rocks, heavier metallic minerals and elements and materials. And they have a higher density than the other planets. They orbit and revolve closer. They are usually slower on their revolution, but they have no rings. They have very few moons, if any. So the only moons in the terrestrial pack basically is the 1 moon for Earth, obviously, and the 2 moons for Mars. So Venus and Mercury do not have moons, and they have a diameter around the equator of less than 13,000 kilometers. So they're smaller planets in general. So Mercury is the closest planet to the Sun. It is pretty similar to the moon's surface in terms of how it appears. It has a revolution of 88 days. It is extremely high temperatures and fluctuations from night and day due to the proximity of the Sun, in terms of 425 degrees during the day to minus 170 degrees at night. So a very large swing of temperature. It was discovered or seen by telescope by Pierre Cassini in 1631, and NASA sent a messenger probe and sensors to the planet for 3 years between 2008 and 2011 to gather data. So this is a great, awesome planet to start with, and the closest to the Sun. Then you got Venus, Earth's twin in terms of the similar size, similar density. However, it does differ with its very thick atmosphere, contains CO2, very hot surface temperature. It's the hottest planet on the solar system. It has no moons and is hotter than Mercury, and 1 day rotation on Venus is longer than 1 year revolution. So a day takes longer than a year on Venus, which is an awesome thing. Then we've got Mars. Mars is our classic red planet. It's called red planet because of the iron oxide in the Martian soil. And it has the largest volcano in the system, Olympus Mons. It has 2 moons, Deimos and Phobos. It has an orbital period, how long it takes to roll around the Sun, is 687 days, and it's roughly 15 million miles from Earth. So it's close, but not too close. It would take about 300 days to travel to Mars using gravitational pull of the Sun, Earth, and going towards Mars. So that is the terrestrial planets. Small, rocky, and dense. Then we get into the asteroid belt. The asteroid belt is that defining separation between the terrestrial planets and the following 4 planets further out that are called Jovian Plants, or gas giants. Now these are generally made up of gases, mostly hydrogen and helium, and they are larger, a lot larger than the terrestrial planets, and they have a less or low density. They have a much larger revolution in terms of distance to travel around the Sun. They're much further out, away from the Sun, and this lighter gas gives the planet its coloration and its density and its composition. So it is based around a rocky core, a metallic core, but most of the mantle or the bulk of the planets are gas. So Jupiter is the first largest gas giant in the order past the asteroid belt, and it was first seen in the 7th century. It is 330 times bigger than Earth in terms of mass, 11 times bigger in terms of diameter, and it takes 12 years for Jupiter to orbit around the Sun, 12 Earth years for 1 revolution of Jupiter. It has 95 moons. Now they keep finding moons. Now previously doing this class, there was 55 moons, then 65, then 80, now up to 95 moons. It does have a faint ring system. This was confirmed in 1979 and then again in 1990, and it has a set of 4 rings. It has a shortest day in the system. It rotates on its axis once every 9 hours and 55 minutes, so it's an extremely large planet, yet it spins extremely quickly. There's a massive red giant spot, which is a storm in the atmosphere, And 8 spacecraft from Earth have taken pictures of Jupiter and done flybys and orbits. Saturn is considered one of the most beautiful planets in our system in terms of the ring system and the coloration. It is, again, made of mostly hydrogen and helium, so it's a gas giant, and it is named by the father of Jupiter. It is extremely fast day, nearly as fast as Jupiter, but it's 10.9 hours for one day, even though it's a massive, huge planet. And you can see it with the naked eye, but again, it's the furthest away you can see with the naked eye in terms of planets. And the ring systems are beautiful and composed of rock and different size materials, and there are billions of rocks in these ring systems. It takes 30 years to orbit the Sun, and the core of Saturn has heavier elements like iron and nickel, and it's surrounded by a liquid metallic hydrogen layer. So it is a mix, but there is a large portion of gas on the outside and the surface as well. Uranus, or Uranus, either way you can say, it's also named after the Greek god of the sky. It's the next planet out. This is a brilliant blue color based on the methane gas in the atmosphere, and it has 11 dark ring systems, and it has 27 moons currently that we found located, and it's a 17-hour rotation. So all these gas giants really do spin on the axis really quickly. And again, similar composition to Jupiter. It is called an ice giant because it's further away from the Sun. It's about 19 AU from the Sun, which is about 2 billion miles, which is a great distance. So it is far away from the temperature and the heat source, so it is considered an ice giant. It's frozen, basically. It was discovered using a telescope, and Voyager 2 has flown by it, and it has a 98-degree tilt compared to our 23.5-degree tilt. So it is really tilted pretty much on the side as it rotates and spins. Then last but not least, the furthest away planet in our system, the 8th planet, is Neptune, and it's blue again because of the methane gas. It takes 165 years to orbit the Sun. It has 14 moons currently, and most of the moons are named after Greek mythology because Neptune was the Greek god of the sea. Now it is 30 AU from the Sun. Don't forget, an AU is the distance between Earth and the Sun, so 93 million miles, so 30 times that. And it's a 16-hour day to rotate on its axis, and it is 17 times the size of Earth in terms of mass. It is huge. Now, in terms of composition, again, it's an ice giant, so it is mostly hydrogen and helium and some methane. Now, I love a good graph, a good table, a good set of data to discuss and look over with the students in terms of comparing and contrasting different parts, or in this case different planets, parts of the solar system, and you've got this amazing set of data in terms of how to compare and try and relate and trying to think about why certain things are the way they are based on the data. So in terms of evolution and how long it takes to orbit the Sun versus the distance, again, it's correlated. The rotation of the axis, maybe based on the composition or the distance or the size. The mass and the density, again, you can correlate based on composition, terrestrial versus Jovian or gas giants. And then the eccentricity is the degree of elliptical shape of that orbit, again based on Newton and Kepler's laws, density, composition, and distance, and obviously Kepler's third law as well, law of harmonies. So amazing system, beautiful contrast in different planets, different makeups and how they function, and our solar system is absolutely amazing. Thank you so much for watching the video.